Hi, this is our physics PIA and my team is composed by
Lucia,
Mauricio,
Gilberto,
Diego, Everardo.
Now, the friction is the force resisting the relative motion of solid surface, fluid layers, and material elements sliding against each other. The coefficient of static friction is a number usually between 0.01 and 1 that measures the ability of two surfaces to slide past one another. When this number is very high, there is a lot of friction between two surfaces. When it is small, there is a little friction. We can measure this coefficient using different ways. One of the most simple and common ones being is the critical angle method that we will use in this experiment. There are different types of friction. Direct friction is a force that opposes the relative lateral motion of two solid surfaces in a contact.
Materials 1. A plane or board of wood. Try to get to apply. The dimensions on the plane had to be at least 0.5 centimeters of thickness, 50 centimeters long, and 20 centimeters in wide. 2. A set of three masses, 0.2 kilograms, 0.4 kilograms, and 0.6 kilograms. 3. A potator to measure angles. 4. Aluminium foil. And 5. Scotch tape. Procedure 1. Place the plane at ground level and the stream A tangent. Make sure that the stream A remains fixed. The only stream that can remove is the stream B. 2. Attach the assigned surface to the base of the container. 3. Place the first mass 0.2 kilograms at the center of the stream B. 4. Very slowly raise the level and the stream B so that the plane passes to a different angle. 5. At some point you will notice that the container starts to slide downwards. Stop raising the plane at that point and record the angle with the potator for which this happens. We call the critical angle. 6. Repeat this process 9 more times and record the critical angle for each repetition. Always make sure that the raise of the plane very slowly and continuously. 7. Calculate the average of critical angle with this 10 repetitions. 8. Finally, calculate the coefficient of friction is equal to the tangent of the angle. 9. Try to same the experiment for the other masses to confirm that the coefficient of friction is the same as before. This confirms the idea the coefficient of friction is independent of the masses and use only depends on the two surfaces being used in the experiment.
Variables dependent friction coefficient of aluminum independent material on the surface aluminum only. Coefficient of friction of aluminum clean and dry condition static friction between 1.05 to 1.35 and sliding friction 1.4. The coefficient of static friction is the rate of the maximum static friction force between the surface in contact before movement commences to a normal force. The coefficient of kinetic friction is the rate of the kinetic friction force between the surface in contact during movement to the normal force. Both the static and kinetic coefficient of friction depend on the pair of surface in contact. Their values are determined experimentally. There is another formula that we also use to calculate the coefficient of friction, which is the tangent to the angle, that in a few moments my partner will explain why this formula.
If the component of the gravity force down, the incline is equal to the frictional force. So we go to this formula that is mass gravity and times sine of the angle is equal mu mass gravity times the cosine of the angle. So isolating this formula, we have that the mu is equal to mass gravity and sine of the angle divided by mass gravity and the cosine of the angle. That is equal to the tangent of the angle.
This PIA was quite helpful in understanding friction and its concept as a force that exists between two surfaces in contact. Also, the friction depends on the nature of the materials that are in friction and the force exerted by one body on another, that is, the normal force.
In my opinion, friction is present on different surfaces that come into contact with different objects, and as we saw in the experiment, the masses of the various objects in relation to the friction of the aluminum foil surface depend on the angle of inclination to that the surface is enclosed, and thus the different objects begin to move and to have a certain coefficient of friction that occurs between the surface and the object.
This PIA project was very interesting since we investigate, checked, and calculate the coefficient of friction of aluminum, reinforcing the knowledge of the semester.
This practice was very helpful because thanks to this we were able to identify in a practical way the relationship between the angle and the coefficient of friction.
Personally, I am very amazed at how the coefficient of friction varies depending on the material we use on the surface. It really amazes me since they are things that happen daily but we do not realize what is happening, talking about the field of physics.
This PI is very interesting to know about the factors that affect the movement. In this case, is the friction between the object and the ground.